Welcome. In this video, we're going to take a look at problem 124 out of Chapter 5 in University Physics Volume 2 by OpenStax. All right, so what we have is a thin rod with charge per length lambda. We need to find the electric force on the point charge Q. Okay, so we can solve the problem by first considering the electric force dF on Q due to a small segment dx of the rod, which contains charge lambda dx. Then we can find the net force dF over the length of the rod. All right, and so what we saw for discrete point charges is that the electric field is 1 over 4 pi epsilon 0 times, for each, we're going to sum up for each charge we have, and we're going to take the charge divided by the distance between the charge and the point of interest, and we're going to square that. All right, so we have a line of charge that's making the electric field, and our point P is over where the Q is. And so we're going to take 1 over 4 pi epsilon 0, and now we need an integral. The charge is going to be the lambda dl over the distance from the line of charge over to the point of interest. And we're going to square that distance. All right, and then we're going to see we can use the integral of x to the n is the quantity that's listed there. All right, so let's start. We know that F is equal to Q times E. So dF is equal to Q times dE. All right, and so dE is going to be 1 over 4 pi epsilon 0. And then we're going to have a lambda, and instead of dl, we're going to have dx because the charge is along the x-axis. Then we'll have the quantity x plus a, and that will be squared. Okay, and so now if we multiply that by q, we will have df. So df will be 1 over 4 pi epsilon 0. Let's do q lambda dx over x plus a quantity squared. All right, and so since there's nothing in the vertical, this will be our force. So if we integrate both sides, we will get F equals, okay, the integral is going to run from 0 to L. We've got 1 over 4 pi epsilon 0 q lambda dx, all divided by x plus a quantity squared. Let's take all the constants out. So we get F is 1 over 4 pi epsilon 0, a q, a lambda. Okay, that's it. We've got 0 to L. We're left with a dx over x plus a quantity squared. All right, we can let u equal x plus a. So this is substitution. Then du is going to be dx. All right, we also have the limits of integration. So when x is 0, we're going to have u is equal to a. And when x is L, we're going to have u is L plus a. All right, so let's make that substitution. Then F is 1 over 4 pi epsilon 0. Let's put our q lambda there. Okay, now integrating over u, starting at a and going to L plus a, we will have du over u squared. Okay, so now we can rewrite this. q lambda over 4 pi epsilon 0 a to L plus a u to the minus 2 du. Okay, and so this is where we can use this guy. Okay, all right, so what we're going to have is f is q times lambda over 4 pi epsilon 0. Okay, let's do parentheses. So we're going to have u to the minus 2 plus 1 over minus 2 plus 1, evaluated from a to L plus a. Okay, let's write what that is. So we have f is q lambda over 4 pi epsilon 0. Okay, minus 2 plus 1 is just minus 1. So we have u to the minus 1 over minus 1, and we need to evaluate it. It's a good idea to factor out the minus 1. So we have f is minus q lambda over 4 pi epsilon 0. U to the minus 1 is 1 over u, and we're going to evaluate it from a to L plus a. And so what we end up with is minus q lambda over 4 pi epsilon 0. We're going to have 1 over L plus a minus 1 over a. And we can write this as a vector as f vector equals, we have minus q lambda over 4 pi epsilon 0, 1 over L plus a minus 1 over a, all in the I hat direction. All right, well, that was done in great detail. I hope you learned a lot and enjoyed the video. I will see you next time.